Hello students, welcome to the class. So in the previous class, we have discussed regarding Ostwald's dilution law, degree of dissociation. We have seen the limitations. Moving to the multiple choice questions regarding equilibrium topic. Hope you have practiced all the concepts which have been explained in equilibrium. Either it is chemical equilibrium or it is ionic equilibrium. Yes. So in chemical equilibrium, we have seen law of chemical equilibrium. We have seen about Le-Chatelier's principal factors governing the chemical equilibrium. We have seen so many constants we have seen. Yes. Then we have also discussed regarding ionic equilibrium, wherein we have discussed about the theories of acids and bases, ionization, strength of acids, and everything, right? So with the first question, in liquid gas equilibrium, the pressure of the vapors above the liquid is constant at. Is it constant at constant temperature, at low temperature, at high temperature, or none of these? So they have said liquid gas equilibrium. Yes, it is a physical equilibrium. Therefore, I can write liquid is in equilibrium with gas. That means a reversible reaction. So it is a liquid gas equilibrium. When we speak about liquid and gas, excuse me, I have told you that when we talk about liquid, yes, it undergoes evaporation and vapors are formed here. They exert a pressure, we call it as vapor pressure. Yes, and we know that this vapor pressure, yes, vapor pressure is what? The pressure exerted by the liquid above the surface of the liquid. That is vapor pressure. So this vapor pressure is what? It is directly related to what? It is directly related to temperature. Yes. Why I say it is directly related to temperature is because when I increase the temperature, more number of molecules get the energy, kinetic energy, thermal energy, which gets converted to the kinetic energy of the molecules. They come into the vapor phase. When more number of molecules are there in the vapor phase, this is called as vapor phase. Yes, vapor phase. And this is called as liquid phase. Right. So when more number of molecules are there in vapor phase, the pressure exerted will be more. Yes. Therefore, vapor pressure is directly related to the temperature. That's the reason I can say greater the temperature, greater will be what? Greater will be vapor pressure. Yes, greater will be the vapor pressure. So to keep it constant, to keep vapor pressure constant, what I need to do? To keep vapor pressure constant, what should be constant? Temperature should be constant. Temperature should be constant. So if temperature is constant, vapor pressure remains constant. Very important point. Yes. So to keep, why we are saying? Because vapor pressure is directly related to what? It is directly related to temperature. It is directly related to temperature. Is that right? So since it is directly related to temperature, I hope you understood how it is directly. See, suppose you have only liquid here, right? Suppose you have only liquid. So what is there? This is the liquid phase. Liquid phase, we call it. Yes. And when, because of evaporation, I'm not boiling here. Okay. Because of evaporation, some molecules, surface molecules will gain energy and come into this gaseous phase. And that is called vapor phase. That is called vapor phase. So these molecules, when they hit the walls, they exert the pressure here. And that pressure is called what? It is called vapor pressure. Pressure exerted by the liquid molecules above the surface of the liquid is called vapor pressure. When you increase the temperature, what will happen? More number of molecules in liquid phase acquire the energy and go into the vapor phase, due to which number of molecules in the vapor phase increases. Therefore, what happens? Therefore, there is increase in the pressure. And that's the reason what happens, the vapor pressure also increases. So if you want to keep this vapor pressure constant, then temperature has to be kept constant. The temperature has to be kept constant. Is that right? So which is the correct one? At constant temperature. Option A is the correct option. Next question. The equilibrium constants of the following are: N2 plus 3H2 gives NH3. N2 plus O2 gives 2NO. H2 plus half O2 gives H2O. Equilibrium constant K of the reaction. Okay. So we are going to, this is what equilibrium depends on the stoichiometric calculations, correct? So here from the given equations. What is the first equation? See, they are here the equations. First equation they have given N2 plus H2 gives NH3. But final equation is what? I'll write final equation first here. They have said 2NH3 plus 5 by 2 O2 gives, this they have said K, 2NO plus 3H2O. Okay. What is the first equation they have given? The first equation they have given as N2 plus 3H2 gives 2NH3. 2NH3. I don't want this equation. I want NH3 on the left hand side as the reactant. Therefore, what I'll do, I'll take NH3 this side. So I will write this reaction as 2NH3 plus, 2NH3 gives N2 plus 3H2, correct? So I got 2NH3 on this one side. Now O2 I want, they have given N2 plus O2 gives what? Gives 2NO. Yes. So what I will do here, they have given this reaction. We will keep this reaction as it is. One more reaction they have given, H2 plus half O2 gives what? H2O. And they have mentioned their equilibrium constant. So they have said this is K1, this is K2, this is K3. See, when I have reversed this reaction, this becomes what? 1 by K1. Correct? Reverse the reaction, it becomes 1 by K1. We have seen this stoichiometric calculations. And 2 plus half O2, I've kept it as it is. So it is K2. Now, third equation, what I will do here is, it is half O2, right? I will make it 3 by 2. Entire reaction, I will write 3 by 2. So what I'll get multiplied by 3. Entire reaction multiplied by 3. So 3H2 plus 3 by 2 O2 gives me what? Gives me 3H2O. When you are multiplying the entire equation by 3, the equilibrium constant becomes K3 cube. The new equilibrium constant becomes what? K3 the whole cube. This is the new equilibrium constant. And second one is remaining as it is. Therefore, when you add all these three equations, see, this is first equation, observe here. This is second equation. I'll write the second equation as it is because we have not done any changes. N2 plus O2 gives 2NO. Yes, and this is the third equation, second, third. Adding equations 1, 2, and 3. Adding equations 1, 2, and 3. What do I get? Yes, when I add equations 1, 2, and 3, observe here, 2NH3 plus N2 plus H2. Here N2 gets cancelled, 3H2 gets cancelled. Understanding? O2 plus 3 by 2 O2 becomes what? 5 by 2 O2, correct? 5 by 2 O2. This is given here. Gives 2NO plus 3H2O. Did we get it? Yes. So you have to get your reactions, given reactions in this order. Then we can calculate the final equilibrium constant. So they have asked us what is the final equilibrium constant K here. Therefore, K will be equal to what? You have multiplied, you have added all the three equations. Therefore, the final equilibrium constant will be, it will be multiplying of all the equilibrium constants, equilibrium constant of first one, equilibrium constant of second one, equilibrium constant of third one. So K is equal to what? Equilibrium for constant of first one is 1 by K1. Of second one is what? It is just K2. And third one is K3 square. Cube, sorry. Therefore, K is equal to what? K2 into K3 the whole square divided by K1. So this is our option. Understood? Whatever the equation is given, final equation, you have to get it to that form. So whatever you need to do, you do, and change the equilibrium constants accordingly. Here I have not done anything, so I have kept it K2 only. But here, reversing the reaction, equilibrium constant will be inverse. Multiplied by 3, it will be cube. Multiplied by 2, it will be square. Divided by 2, it will be root of the new equilibrium constant. Yes. So with that, I will get K2 into K3 the whole cube divided by K1. So option A is the correct option. Option A is the correct option. Next, if the equilibrium constant for the reaction N2 plus half O2 gives 2NO, is K. The equilibrium constant for half N2 plus half O2 gives NO. What it is? See, what is done is the first equation is N2 plus O2 gives 2NO. What they have done, divided the whole equation by 2. When you divide the whole equation by 2, it becomes 1 by 2 N2 plus 1 by 2 O2 gives 2 by 2 is nothing but 1 NO, correct? This is what we get. The old equilibrium constant is K. Then what is the new equilibrium constant? The new equilibrium constant will be what? It will be the root of K, old equilibrium constant, or I can write K raised to 1 by 2. Just now I have told. When you multiply it by 2, the new equilibrium constant will be the square of old. When you multiply it by 3, the new equilibrium constant will be cube of the old. When you divide it by 2, the new equilibrium constant will be root of the old one, or 1 by 2. Yes. So if the reaction is multiplied by 1 by 2 or divided by 2, the new equilibrium constant will be K raised to 1 by 2. So it is option D, which is the correct option. Is that right? Option D is correct. Next question, given that the equilibrium constant for the reaction 2SO2 plus O2 gives 2SO3 has a value of 278 at a particular temperature. What is the value of equilibrium constant for the following reaction at same temperature? SO3, SO2 plus half O2. Okay, see, very good question it is. What they have said here is, they have given the reaction. The reaction given is 2SO2 in the gaseous form plus O2, which is also in gaseous form, reversible reaction, 2SO3 gaseous. Okay, so they have given the equilibrium constant to be 278. Fine. Let us call this equation as 1. Now see, when they have given us the second equation, it is reverse of this. I don't say it is only reverse of it. Let us see. Reverse of equation 1. Reverse of equation 1 will be what? Will be 2SO3 gives 2SO2 plus O2. Correct? This will be the reverse. So when you reverse this, let me call this equation as equation 2. When I reverse it, the equilibrium constant will change. So equilibrium constant for equation 2 will be what? K dash will be equal to inverse of K according to the rules. Therefore, that will be equal to 1 by 278. Is that right? Yes. Then what you do, so keep it like that only. Further, the second equation, they have given us, yes, in the equation half O2 is there. So let us say divide the equation by 2. Next, divide equation 2 by 2. When you divide the equation 2 by 2, 2 by 2 SO3 becomes SO3 only. Then it is in gaseous state. Then here we have equilibrium existed. 2 by 2 is again 1 SO2 gaseous plus half O2, which is also in gaseous. Did we get the final reaction which they have said? Yes, they have said SO3 gives SO2 plus half O2. So when you divide the entire reaction by 2, what we do? The equilibrium constant for equation 3, let me call this as equation 3, will be what? K double prime. This is different, right? So when you are dividing it by 2, it will be root of K, which is this. Yes. Therefore, that is nothing but what? Root of 1 by 278. Solve it out. You'll get the answer 0.0599. This is the answer what we get, which is approximately equal to 0.06. Yes. Approximate rounding off. 9 is more than 5. So this becomes 6, or I can write it as 6 into 10 raised to minus 2. Correct? Shifting the decimal point 2 digits to the right, it becomes minus. So whichever is given, that will be the correct option. So what is correct option? It is 6.0 into 10 raised to minus 2. Is that understood? Yes. So this is how we solve it. Okay. Next question. Given the reaction between two gases represented by A2 and B2 to give the compound AB, gaseous. So two gases are there, A2 and B2. They are diatomic. So homonuclear diatomic gases, they are giving us a gas that is AB. That is a compound, it is AB in gaseous state. At equilibrium, the concentration of A2 is so much, B2 is so much, and AB is so much. If the reaction takes place in a sealed vessel at 527 degrees Celsius, then the value of Kc will be. Okay, so let us solve it. Lot number of numericals we come across here. So what is the reaction they have given? They have said A2 gaseous plus B2 which is gaseous gives me what? Gives me 2AB. 2AB which is also gaseous. They have given us the values, right? Concentration of A2. You can represent it like this. Molar concentration of A2 is equal to how much they have given? 3.0 into 10 raised to minus 3 molar. Molar concentration of B2. 4.2 into 10 raised to minus 3 molar. Molar concentration of AB. How much? 2.8 into 10 raised to minus 3 molar. Correct? Now they have asked us to find Kc. Can you write Kc for this equation? Yes, very well we can write. So Kc will be equal to what? Kc will be equal to concentration of AB raised to 2 upon concentration of A2 into concentration of B2. Is that right? Okay, solve it out. Kc is equal to concentration of AB is 2.8 into 10 raised to minus 3 the whole square upon 3 into 10 raised to minus 3 plus 4.2 into 10 raised to, not plus, into 10 raised to minus 3. Correct? So 10 raised to minus 3 is a square and this gets cancelled. What remains? 2.8 divided by 3 into 4.2. It is into, okay, product it is. So here we can solve it out. 2.8 into 2.8 divided by 3 into 4.2. Correct? And this comes out to 0.62. Solve it out and see, it comes out to 0.62. So this is how we calculate the equilibrium constant. Yes, option C is the correct option. Yes, next question. For a reaction N2 plus O2 gives 2NO, the equilibrium constant is K1. The equilibrium constant is K2 for the reaction. 2NO plus O2 gives 2NO2. What is K for the reaction? NO2 plus gives half N2 plus O2. 1 by 2 K1 K2, 1 by 4 K1 into K2, 1 by K1 into K2 the whole raised to 1 by 2 or 1 by K1 into K2. Okay, again write the reactions. What are the reactions given? Tell me. Okay. So what are the reactions given here? N2 plus O2 gives 2NO, gaseous, okay? And they have said this is what? This is K1. Then they have given the reaction 2NO plus O2 gives 2NO2. And they have said this is K2. Further, they have asked us NO2 they have given, and NO2 gives half N2 plus O2, and they have said it is K. And what is K they have said? Correct? What is the K they have asked? Now see, can I write K1? Okay. Look at the equation 1. I will call these equations. Equation 1, this is equation 2, this is equation 3. Look at the equation 1 and tell me what will be K1. K1 will be equal to molar concentration of NO raised to square divided by molar concentration of N2 into molar concentration of O2. Correct? Okay. Similarly, what is K2? K2 will be molar concentration of NO2 raised to square divided by molar concentration of NO square molar concentration of O2. Correct? And what will be K? Yes, what will be K? Here it is, this is N2. Okay. So what will be K? It is equal to molar concentration of N2 raised to half into molar concentration of O2 divided by molar concentration of NO2. Molar concentration of NO2. Yes, which is nothing but root of molar concentration of N2 into molar concentration of O2. Yes, we get this by solving these two, right? Divided by molar concentration of NO2 the whole square into molar concentration of NO the whole square into O2 concentration divided by NO2 the whole square. NO2 the whole square, correct? So what is this? This is nothing but K is equal to, yes, root of, what is this? N2 into O2 by NO2, N2 into O2 by NO2, N2 into O2 by NO2. So it is 1 by K1. 1 by K1, correct? NO square into O2 into NO2 whole square. This is 1 by K2. Therefore, can I write this equation as K is equal to root of 1 by K1 into K2. Yes, 1 by K1 into K2. Understood or no? Yes or no? So this is how we get this equation. Solving this equation, we'll get this final answer. So which is the correct option? So it is correct option is root of 1 by K1 into K2. So 1 by K1 into K2 raised to 1 by 2. Option C is the correct option. Next question. The dissociation constants for acetic acid and HCN at 25 degrees Celsius are 1.5 into 10 raised to minus 5 and 4.5 into 10 raised to minus 10 respectively. The equilibrium constant for the equilibrium Cn minus plus CH3COOH gives HCN plus CH3CO minus would be. Option A is 3.0 into 10 raised to minus 5. Option B is 3.0 into 10 raised to minus 4. Option C is 3.0 into 10 raised to 4. Option D is 3.0 into 10 raised to 5. Okay, let us solve it out. Now see here, they have said acetic acid and HCN, hydrogen cyanide. Acetic acid is what? Acetic acid is CH3COH. So given, they have given dissociation constants for acetic acid and hydrogen cyanide. So let us write it. What is given? Acetic acid, CH3COOH, it is a weak acid. Therefore, it dissociates partially to give CH3COO minus plus H plus. Okay. And it's a dissociation constant they have given. So I'll consider it as K CH3COH, or write K1. That is equal to what? Concentration of CH3COO minus into concentration of H plus, the whole divided by CH3COOH. Correct? And that value they have given it as 1.5 into 10 raised to minus 5. 10 raised to minus 5. This is the value given. Similarly, they have said hydrogen cyanide, HCN, dissociates to give H plus plus Cn minus. Again, a weak acid. Write the dissociation constant. Either call it as K2 or you can call it as K of HCN. Gives me what? H plus concentration into molar concentration of Cn minus, the whole divided by molar concentration of HCN. Correct? HCN. Yes, box bracket. Okay. And this value they have given it as 4.5 into 10 raised to minus 10. 10 raised to minus 10. And then they have said the reaction as Cn minus plus CH3COOH is in equilibrium with CH3COO minus plus H plus. Yes. Then write the dissociation constant for this. K is equal to, I will get, okay, So it is CH3, molar concentration of CH3CO minus into molar concentration of H plus divided by molar concentration of CH3COOH into molar concentration of Cn minus. Yes, molar concentration of Cn minus. Correct. So this is what I get. Understanding? Using these two, solve it out. Solve it out. You will get the answer. They have given this and they have given this. So CH3CO minus into H plus divided by CH3COH into H plus into Cn minus divided by HCN. So when we solve it out, we will get the answer 3.0 into 10 raised to 4. 3.0 into 10 raised to 4. So which is our correct option here? 3.0 into 10 raised to 4. It is option C. We will get option C. Okay. Then very simple question. The value of equilibrium constant of the reaction HI gaseous gives half H2 gaseous plus half I2 gaseous is 8.0. The equilibrium constant of the reaction H2 plus I2 gives to HI will be. Direct question it is being asked. So what they have said, they have given the reaction HI in gaseous form. It dissociates to give me half H2 gaseous plus half I2 gaseous. I2 gaseous, right? And its dissociation constant. How do you write it? K H2 raised to 1 by 2, I2 raised to 1 by 2 divided by concentration of HI is how much they have said? They have said it is 8. And they have asked for H2 plus I2 gives 2HI. 2HI. What is the dissociation constant? New dissociation constant, K prime. So K prime will be what? HI raised to square divided by H2 into molar concentration of I2. H2 into molar concentration of I2, correct? So here, the new dissociation constant, when what is the reaction happened? The entire reaction is multiplied by 2. Yes, it is multiplied by 2. It is reversed first and multiplied by 2. So it will be 1 by 8. 1 by 8 when it is reversed. Multiplied by 2 means what? Square. So it will be what? It will be 1 by 64. Understood? Reversing the equation becomes, so K dash is what? On reversing. On reversing, they have reversed the equation, right? On reversing, it becomes 1 by K. That is 1 by 8. Then after that, what they have done, K double prime, they have multiplied the equation by 2. So when you multiply the equation by 2, K dash will be square. So 1 by 8, the whole square is what? 1 by 8 square, that is 1 by 64. So 1 by 64 is the correct option. Let us see which is the correct option. It is option D, that is 1 by 64. Correct? Okay. Next question. Equilibrium constants K1 and K2 for the following equilibria, NO plus half O2 gives NO2, it is K1, and N2O, 2NO2 gives 2NO plus O2, it is K2. They are related to. Okay. Again, a good question here. So what they have said, they have given us two reactions, equilibrium constants for the following equilibria. Okay, let me write the reactions. It is NO gaseous plus half O2 gives NO2 gaseous. This they have called as K1. And one more equation is 2NO2 gaseous gives 2NO gaseous plus O2 in gaseous state. And this they have called it as K2. So according to this, write the equilibrium constants. Equilibrium constant K1 will be equal to molar concentration of NO2 divided by molar concentration of NO into molar concentration of O2 raised to 1 by 2. What they have done, they have reversed the reaction. Okay, let me write here equilibrium constant K2. It is molar concentration of NO, the whole square, into molar concentration of O2 by molar concentration of NO2, the whole square. So what they have done, just observe properly. They have, this is the first reaction, they have reversed the reaction. So K1 is okay. K2 have to write, right? Okay. K2 is what? It is the reverse. Therefore, I will write 1 by K1. 1 by K1. So when you do 1 by K1, you will get the new equation K2. Then further what they have there said that they have multiplied the entire reaction by 2. So the new K3 will be what? It will be K2 the whole square. K2 the whole square. Therefore, the new equilibrium constant they have taken only as 2 because both the things they have done in one step only. Therefore, I can write K2 is equal to first inversing and then multiplying the reaction by 2, it becomes square. Yes, it becomes square. Therefore, K2 will be equal to what? 1 by K1 the whole square. 1 by K1 the whole square. So how are K2 and K1 linked? K2 is equal to 1 by K1 the whole square. Is that right? So which is the correct option? K2 is equal to 1 by K1 the whole square. It is option A, which is the correct option. Yes? Okay. If K1 and K2 are the respective equilibrium constants for the two reactions, XeF6 plus H2O gives XeOF4 plus 2HF. XeO4 plus XeF6 gives XeOF4 plus XeO3F2. The equilibrium constant of the reaction XeO4 plus 2HF gives XeO3F2 plus H2O. See, very beautifully they have framed the question taking stoichiometric calculations. Okay, what they have said, first they have given the equations. Let us write these equations. XeF6 plus H2O gives XeOF4 plus 2HF, correct? And they have said the equilibrium constant K equilibrium is equal to what? They have said K1. Okay. Then they have written second equation XeOF4 plus, what I will do, I will reverse this because in my given final equation, it is reverse, right? HF should come on the reactant side. So I will reverse it. So it becomes 2HF gives XeF6 plus H2O. So what will be the equilibrium constant here? So K equilibrium will be 1 by K1. 1 by K1. Okay. Then next thing what they have done, shall we keep it as it is, the second equation? Yes, we have to keep it as it is. XeO4 plus XeF6 gives XeOF4 plus XeO3F2. Okay, and they have said the equilibrium constant K equilibrium is equal to K2. They have mentioned it as K2, correct? Okay, so we have not done any changes. Over here. Okay, how do we solve it now? The final reaction is what? Final reaction is, they have given XeO4 plus 2HF gives XeO3F2 plus H2O. This can be obtained. How do you obtain this equation? How do you obtain this reaction? This can be obtained by adding equations 1 and 2. By adding equations 1 and 2. That is equation 1 and this is equation 2. When you add these two equations, we'll get the final equation. Yes. So the equilibrium constant for the above reaction can be obtained by multiplying. When you are adding these two equations, what is the final equilibrium constant? K. The final equilibrium constant we can obtain by multiplying the two equations. So multiply the two equilibrium constants. It is 1 by K1 into K2. So what is the option? Correct option? K is equal to K2 divided by K1. This is the final option. K is equal to K2 by K1. Okay, the final equilibrium constant for the new reaction or mentioned reaction will be what? It will be K is equal to K2 by K1. Yes. So let us see which is the correct option. K2 by K1. So option D is the correct option. Option D is the correct option. Next question. The equilibrium constant for the reaction N2 plus 3H2 gives 2NH3. What is this reaction, students? It is manufacture of ammonia by Haber's process. Please do remember, they are in gaseous states. Is K. Then the equilibrium constant for the equilibrium, this is, okay? Take it out and solve it immediately and tell the answer. So they have given the reaction N2 gaseous plus 3H2 gaseous gives what? Gives 2NH3. Yes, and it is in gaseous form. They have given the equilibrium constant, equilibrium K equilibrium is equal to K for this reaction. And they have asked for 2NH3. I'm sorry. 2NH3 gives N2 plus 3H2. So what they have done, simply they have reversed the reaction. Therefore, the new equilibrium constant will be 1 by K. The equilibrium constant for a reverse reaction is what? Equilibrium constant for a reverse reaction is what? Is inverse of the equilibrium constant Kc. It is the inverse. Yes. So it is inverse. Therefore, which is the correct option? The correct option is 1 by K. 1 by K. Next one. K1 and K2 are the equilibrium constants for the reaction. N2 plus O2 gives 2 NO. NO gives half N2 plus O2 respectively. So they have asked the relationships. Take the reaction, solve it out and tell the relationship. What is done on the equation you should be knowing. That's it. So let us write the reactions. Okay. The reactions are N2 plus O2 gaseous gives 2 NO. And they have said this is the equilibrium constant K1 for this. And second one is NO gives half N2 plus half O2. So what they have done here for students, they have reversed the reaction. And this is K2 they have said. So firstly, they have reversed the reaction. So reversing is not being given here. 2 steps they have done. What are the 2 steps they have done? They have reversed the reaction first. Reversed the reaction. And second thing, they have divided the reaction by 2. Correct. These are the 2 things what are done. So let us see what we can do. On reversing, K new equilibrium constant becomes. Yes. The new equilibrium constant on reversing becomes what? It becomes 1 by K1. Okay. This K1 is not given. K prime is not given. Directly they have said K2. That means both the things have to be done. They have divided the reaction by 2. So it is 1 by K1 the raised to 2. Yes. So K1 is equal to K2 is equal to root of 1 by divided. So divided means what? 1 by 2. Or I will write it as K2 is equal to root of 1 by K1. So when you multiply, reverse the reaction, I am repeating it, reverse the reaction, the new equilibrium constant will be inverse of the old. Multiply it by 2, the new equilibrium constant will be square of the old. Multiply it by 3, the new equilibrium constant will be cube of 3. Divide it by 2, the new equilibrium constant will be root of the old, or you can write it as K raised to 1 by 2. So it is K2 is equal to 1 by K1 square root, or raised to 1 by 2, or this can I can also write this as, yes, this can be also written as K1 is equal to 1 by K2 the whole square. Yes or no? Because squaring both the sides, we get this. Understanding what I'm saying? What I did is here I will square both the sides. So K2 square is equal to 1 by K1. Root goes off. Now this is K2 square is equal to 1 by K1. Now therefore, what will be K1? K1 will be equal to 1 by K2 the whole square. Yes. So which one I'm having the option? I will write that option. So it is option what? K1 is equal to 1 by K2 the whole square. So you have to arrive at your options. That's it. Yes. Next question. The reaction 2A gaseous plus B gaseous gives 3C gaseous moles plus D gaseous moles is begun with the concentrations of A and B both at an initial value of 1 molarity. When equilibrium is reached, the concentration of D is measured and found to be 0.25 molarity. The value of the equilibrium constant for the reaction is given by the expression. Yes. Okay. So what is being said there? They have said that there is a reaction. So let me write the reaction. 2A gaseous. Okay, I will take it bit this side so that here I can write the concentration terms. So 2A, which is in gaseous, I hope they have given A only. Yes, plus B, which is also in gaseous state, is giving me 3C gaseous plus D in gaseous form. Right? Okay. So let us first see here. What is the initial moles? Initial moles, they have said in the reaction, they have said what they have mentioned. They have mentioned that it is begun with the concentrations of A and B both as 1 moles. So it is 1 mole. And this is also 1 mole. And here it will be what? Initial moles, it will be 0. Reaction has not started that time. Okay. Then what? How many moles will be there at equilibrium? Moles at equilibrium. Equilibrium. So if some amount of X has got converted, some amount of this A and B have got converted into reactant. And they have said it is measured that concentration of D is found to be 0.25. Therefore, I can say moles at equilibrium 1 minus, there is 2 coefficient, 2 into 0.25. Okay, so this is 0.25 they have said, correct? So this is 0.25 moles. This is how much? 3 into 0.25, correct? And this will be 1 minus 2 into 0.25 and this will be 1 minus 0.25. Understanding? So 0.25 has been obtained. Therefore, we did all this. So solve it out. Here you solve it. 2 into 0.25 minus 1. You will get the answer 0.5. 1 minus 0.25. You will get the answer 0.75. 3 into 0.25. 0.75. And here you will get 0.25. Correct? So equilibrium constant Kc. How do you write? Molar concentration of C raised to 3 into molar concentration of D upon molar concentration of A raised to 2 into molar concentration of B. So what is molar concentration of C? 0.75 the whole cube into molar concentration of D is 0.25, getting molar concentration of A is 0.5 the whole square into molar concentration of B is 0.75. Yes, solve it out. So, or you need not solve it. They have given in this expression, right? So what is the expression they have given? 0.75. Okay, I'll write it here. 0.75 the whole cube into 0.25 divided by 0.5 the whole square into 0.75. Yes. So see which holds our answer. So which is the correct answer? 0.75 the whole cube into 0.25 divided by, no, 1 doesn't come. 0.5 the whole square into 0.75. Is this the correct option? Anything else against like this? No. So option B is the correct option. 0.75 the whole cube into 0.25 divided by 0.5 the whole square into 0.75. Yes, that is the correct answer. Next question. The dissociation equilibrium of a gas AB2 can be represented as, so it dissociates as AB plus B2. Degree of dissociation is X and is small compared to 1. the expression relating degree of dissociation with equilibrium constant Kp and a total pressure P. Okay, total pressure P. So everything has to be included. Okay, so let us see how we can solve it out. So equation given is there is a gas AB2 gaseous which dissociates to give 2AB plus B2. Correct? It is giving like this. So now what they have said, the degree of dissociation is X. So here we have started with what? AB2 equilibrium constant. So 2, therefore 2 moles. This is 0. This is also 0. How? When I'm speaking initially. Initially. Correct? 2. So this is 0 because there are no products formed. At equilibrium. Yes. At equilibrium, what happens? X is the degree of dissociation. Therefore 2 into 1 minus X. And here also X, here also X, I'll write. But here there is 2 coefficients. So 2X. Correct. So can I write here amount of moles at equilibrium? At equilibrium. So what is the amount of moles at equilibrium? That is equal to 2 into 1 minus X plus 2X plus X. Correct? 2 into 1 minus X plus 2X plus X. Solve this out. 2 minus 2X. Minus 2X plus 2X gets cancelled. So it remains 2 plus X. This is what it remains. So this is what amount of moles at equilibrium. Now they have asked us what? They have asked us Kp. So in terms of partial pressures, equal to what for this reaction? Partial pressure of AB raised to 2 into partial pressure of B2 divided by partial pressure of AB2 the whole square. Yes, okay. So Kp is equal to, we know that AB is being given. So I will substitute the values here and I will write, I'll take distinction here. Okay, let us write it now. So partial pressure of A, it is AB. Partial pressure of AB, the whole square it is. So this comes out to 2x. AB is 2x by, so how much amount of moles at equilibrium? It is 2 plus x. This is into P, the whole square, because there is square here. B2 is what? B2 is x by 2 plus x into P divided by, what is partial pressure of AB? It is 2 into 1 minus x divided by 2 plus x into P, again the whole square because the coefficient is there. Solve this out. It will come to 4x cube divided by 2 plus x into P divided by 4. Yes, when you solve it out entirely, it comes out to this. Further, therefore, I'll solve it here. Kp will be equal to what? Kp will be equal to 4x cube into P divided by 2 into 1 by 2. Because, excuse me, because why? Because here 1 minus x is almost equal to 1, they have said, and 2 plus x will be equal to what? It is 2. It is equal to 2. Therefore, I can write, therefore, here it will be equal to what? Kp will be equal to 8, 4. So here I can write 8 Kp or x equal to, let me find it for x. X is equal to 8 Kp by 4P raised to 1 by 3. 1 by 3. That can be written as x is equal to 2 into Kp by P. So 4 ones are 4 twos are 8 raised to 1 by 3. Yes, solve it out, we will get this answer. 2 into Kp by P raised to 1 by 3. So which is our correct option? 2 into Kp by P raised to 1 by 3. Option D is the correct option. Is that right? Okay. The values of Kp1 and Kp2 for the reactions. X gives Y plus Z and A gives 2B are in the ratio of 9.1, 9:1. If the degree of dissociation of X and A be equal, okay, degree of dissociation of X and A be equal, then total pressure at equilibrium 1 and 2 are in the ratio of. So this is a bit a lengthy question to explain actually. Yes, see what actually here we can explain is, I will consider it in two halves. Let us discuss like this. Fine. They have said two equations. X gives Y plus Z and A gives 2B. So these are the two reactions. If you consider the first reaction, X gives Y plus Z. Yes. So initially, if I talk about how many moles of X? 1. And Y will be 0. This is when initially. Correct? Okay. And at equilibrium, X, let me say alpha is the degree of dissociation. Alpha is dissociated molecules. So how much will be remaining? 1 minus alpha. And this will be alpha and alpha. Because there is no coefficient, so both are alpha. Similarly, for the equation A gives 2B. Initially, this is 1. This is 0. So this is initially. At equilibrium, they have said the values, if the degree of dissociation of X and B is equal. So again, here also I will consider alpha as equilibrium. Therefore, I write here at equilibrium, remaining is 1 minus alpha, and this is alpha. Since coefficient is there, it is 2. So in this first equation, total number of moles are how much? Total number of moles is 1 minus alpha plus 2 alpha. Correct? 2 alpha. This comes out to what? It comes out to 1 plus alpha for first equation. For second equation, total number of moles at equilibrium will be equal to what? 1 minus alpha plus 2 alpha. That also comes out to 1 plus alpha. 1 plus alpha. Yes or no? So please do remember these two. Now calculate Kp1. Kp1 is what? Kp1 is equal to partial pressure of Y into partial pressure of Z divided by partial pressure of X. What is partial pressure of Y? Alpha divided by 1 plus alpha into alpha divided by 1 plus alpha, the whole divided by 1 minus alpha upon 1 plus alpha. Is that right? Yes. Here into P1 becomes P1 square, and here into P1. Correct? Pressure has to be multiplied. So this entirely comes out to Kp1 will be equal to, solve it out, alpha square into P1 and P1 square, 1 cancels, P1 remains at the numerator, 1 plus alpha into 1 minus alpha. This I get. Similarly, solve it out for Kp2. Partial pressure of B raised to 2 upon partial pressure of A. That solve it out. Partial pressure of B is 2 alpha upon 1 plus alpha square into P1 upon, it is 1 minus alpha upon 1 plus alpha. Solve it out. You will get the answer as 2 alpha square into P2 divided by 1 plus alpha and 1 minus alpha. So this is for K1 and this is for K2. Correct? Now what we are going to do? Now we are going to divide dissociation constant of P1 and P2. So when you divide it, you will get P1 upon 4 P2. P1 upon 4 P2. Yes. That is equal to what? I can write Kp1 upon Kp2 is equal to, P1 is given ratio 9 upon 1. 9:1. Yes. That is equal to P1 upon 4 P2, correct? They have given here P1 upon 4 P2. Okay, P1 P2 is 9:1. So 9 upon 1 is equal to P1 upon 4 P2. So solve it out. P1 by P2 will be equal to what? P1 by P2 will be 9 into 4 by 1. So 9 into 4 is 36 by 1. Therefore, what will be the ratio? The ratio will be 36:1. Understood what we have done? I have written here. I have calculated the total number of moles here. And for second equation, we have calculated the total number of moles. Kp1 I have found out. Got the answer here. Kp2 I have found out. I have got the answer. Then what we have done? We have taken the ratio of Kp1 upon Kp2, which will comes out to P1 upon 4 P2. Now I know that Kp1 upon Kp2 is equal to what? 9 by 1. Therefore, 9 by 1 is equal to P1 upon 4 P2. Therefore, P1 upon P2 will be 36:1. So which is the correct option? The correct option is option A, 36:1. A 20-liter container at 400 Kelvin contains carbon dioxide at pressure 0.4 atmosphere and an excess of strontium oxide. Neglect the volume of solid SrO2. The volume of the container is now decreased by moving the movable piston fitted in the container. The maximum value of the container when pressure of carbon dioxide attains its maximum value will be given. Strontium carbonate dissociates as strontium oxide and carbon dioxide, and Kp is 1.6 atmosphere. Directly the equation is being given, so you need not worry. You can solve it directly. Okay, so how do we solve it? Let us see. So here strontium carbonate SrCO3 dissociates as strontium oxide plus CO2, and they have given Kp is equal to 1.6 atmosphere. Let us write Kp is equal to partial pressure of strontium oxide, partial pressure of carbon dioxide divided by partial pressure of strontium carbonate. Therefore, I can write here 1.6 is equal to strontium oxide solid it is. This is solid, this is solid, this is gaseous. Solid can be neglected, they have said. Therefore, it is nothing but partial pressure of carbon dioxide. Understood? Therefore, maximum pressure of CO2 will be equal to what? 1.6 atmosphere. Okay, so let the maximum pressure, let maximum volume now of container when pressure of CO2 is how much? Is 1.6 B VL, volume VL. So during the process, PV is equal to what? PV is equal to constant. Therefore, pressure is how much? It is given pressure is 0.4 atmosphere into volume 20 liter of the container is equal to 1.6 into V. Correct? P1 V1 is equal to P2 V2. Therefore, what is V? 0.4 into 20 by 1.6. Solve it out, you will get answer 5 liters. So the correct option is 5 liters. Yes, next question. In which of the following equilibrium Kc and Kp are not equal? See, we know that they have given these equations. Okay, I'll write those equations also, or we will take it here itself. We know that Kc and Kp are related how? Kp is equal to what? Kp is equal to Kc RT delta N. That is number of gaseous moles. Delta N is total number of gaseous moles. Correct? So, the difference in the number of moles of the products and the reactants in the gaseous state. If it is not equal to 0, then we can relate it out. If it is equal to 0, then Kp we cannot find it out, right? Because if this becomes equal, Kp will be equal to Kc. So here, how much is delta N? Delta N is 2 minus 2 equal to 0. Correct? Here, delta N. If the delta N is 0, Kp will be equal to Kc. Okay. So here, delta N, 2 minus 2. All are gaseous. So 2 minus 2. Again, equal to 0. Here delta n, 2 minus 2 again equal to 0. Here delta n, it is 2 minus, this is solid, I will ignore it out. There is 1 that is equal to 1. That means it is not equal to 0. So here Kp is not equal to Kc. Kp is not equal to Kc. Otherwise, in all these equations, Kp is equal to Kc. Is that understood? Next, if the concentration of OH minus ions in the reaction FeOH thrice gives Fe plus 3 OH minus is decreased by 1/4 times, then the equilibrium concentration of Fe plus 3 will increase by. Okay, let us solve it here. So the equation is FeOH thrice gives Fe plus 3 OH minus. How do you write the equilibrium constant? Kc will be equal to concentration of Fe plus 3 into concentration of OH minus raised to 3 divided by molar concentration of FeOH thrice. Correct? So they have said it is decreased by 1/4 times. Okay. See, I can write here equilibrium constant will be equal to Fe plus 3 into OH minus raised to 3. The reason why I'm writing it here like you can see here, this is in solid state. So activity of solid is taken to be unity, that is 1. Therefore, it becomes like this. Fe raised to plus 3 into OH minus raised to 1. So concentration of OH minus ions in the reaction, it is decreased by 1/4 times. Then equilibrium constant of Fe plus 3 will be increased by how much? It is decreased by 1/4 times. Then equilibrium constant will be increased by 64 times in order to keep the value of Kc constant. So it will be increased by 64 times. Got it? So this is 3. So it will be increased by 64 times. Next question. Equilibrium constant Kp for the following reaction. Magnesium carbonate, MgO plus CO2. Now you can see here, this is solid. Magnesium carbonate is also solid. Therefore, Kp will be equal to what? It will be P partial pressure of CO2 only. Solids do not exert any pressure. So their partial pressures are taken as unity. Their partial pressures are taken to be equal to 1. They do not exert any pressure. Therefore, it is taken to be unity. So option A is the correct option. Next question. If the value of equilibrium constant for a particular reaction 1.6 into 10 raised to 12, then at equilibrium, the system will. See, the value of K is high means what? This is high, right? Value of K is high and more than 10 raised to 3. Value of K is high means the reaction proceeds almost to completion. That means if it is proceeding almost to completion, then what will happen? The system will contain mostly what? It will mostly contain products. So it will contain mostly products. If it is very less, say 10 raised to minus 3, then it will have reaction has hardly started. The reaction will contain only reactants. But it is more, it is very large. So if K is large, reaction almost completes. And majorly the reaction will contain mostly products. So option A is the correct option. So we have discussed around 20 questions. For the next, we will be discussing the next set of questions. Please practice all the concepts. Thank you.